Hi, my name is Charlie, and you can also call me the guitar boy. Today we are going to be answering this physics question on the board. It's Uniben Post UTME Pass question 2023/2024 section number 2 engineering slash physical science. The question says a wire is stretched by 8 millimeter when a load of 60 Newton is applied. What will be the extension of a wire of the same material having 4 times the cross-sectional area and twice the original length when the same load is applied? Now let's read again. The wire is stretched by 8 millimeter when a load of 60 Newton is applied. What will be the extension of a wire of the same material? Underline this word, the same material, having 4 times the cross-sectional area and twice the original length when the same load is applied. And you have your options on the board. Now, in order for you to solve this problem based on the parameters given here, you know that, and based on the question itself, you know that the formula, this particular question is under elasticity. And even though it's under elasticity, based on the parameters given and what we are asked to calculate from this particular question, the only formula that fits into solving this particular question is Young modulus. And you also notice from this question that this particular question has 2 parts. It say a wire is stretched, and here now say a wire is stretched by 8 millimeter when a load of 60 Newton is applied. What will be the extension of a wire of the same material? Now you have first extension here. Now they are asking you what will be the extension of a wire of the same material having 4 times the cross-sectional area and twice the original length. So this question is apparently of 2 parts. So let us first of all outline the parameters before we go straight to solving the problem. Now, he said a wire is stretched by 8 millimeter. That is extension. When you hear the English stretched by, they are talking about extension. That's E is equal to, with right solution, we are going to manage the board. E is equal to 8 millimeter when a load of 60 Newton. F is equal to 60 Newton is applied. What will be the extension of a wire of the same material? Now, what will be the extension of a wire of the same material? That is another extension, which means this one will automatically be E1, this one will be F1. So E2 is what they want us to calculate. What would be the extension of a wire of the same material, which means we are going to be working on the constant of Young modulus, because if they were different material, we wouldn't have been able to use Young modulus. So because of the constant, because we are talking about the same material here. So the cross-sectional, they say having 4 times, what will be the extension of a wire of the same material having 4 times the cross-sectional area, which means we have area 1, area, if we call A1, let's say A1 is A, then A, they said having 4 times is cross-sectional area, then A2 will be what? 4A, because they say 4 times of the origin of the former one. So which means if A1 is A, A2 will be 4A, the cross-sectional area, and twice the original length. You know, original length, let's say original length is L1, which is equal, well, let's say original length, which is L1, let's say is equal to L. Then they said it's twice the 2. L2 will now be what? L2 is equal to 2 times L. If L1 is L, L2 will be 2 times L, the original length, when the same load, which means F2, they said the same load, F2 is equal to 60 Newton. Now, we cannot apply the use of Young modulus, the formula Young modulus, which is represented as follow: force all over area divided by extension all over original length. This is the formula for Young modulus, which will give us of F all over A times L all over E. Or let me further simplify it so that for those of you who do not understand, so look at it: F all over A divide E all over L. So from this particular formula we have of Young modulus, we can further simplify it to be equal to F all over A. You know, changing this division sign to multiplication sign. To change this division sign to multiplication sign, it will only affect only this side. Then how will it affect it? If you just move this L up, move this E down. So put my times here, L will come up and E will come down. So that is the effect of changing this the division sign to multiplication. Therefore, Young modulus will now be equal to FL, because F times L will give you FL all over AE. So, you know, you also know from this question that F is constant. How? From the question, even though it was not stated directly in the question that F is constant, but from the question they told you that F is the same, because they said the same load, which is the same force, is applied. So if from our parameters, you see that force is 60 here, force is 60 here. That was why I wrote it 60 60. So F is constant, which means we don't need this value of F in this calculation at all. So we are going to remove F now, add it to the side of Young modulus and begin to see it, the F and the Young modulus, as constant. So we don't need it, since this particular question has two parts that are proportional to each other. So we bring this F here. You now have this one will now lead us to something like this: Young modulus all over F equal to, then this one come here, it will not be, this one will not remain, this one will not be remaining A E. So everything here is now constant. So this is what we are going to be using. So we cannot say, right from this formula we have here now, we cannot write our equation here now to be what? L1 all over A1 E1. Why? Because of the two parts. So without getting here first, we cannot write this. So that was the essence of getting here first, to remove all our constant to one side so that we can have our formula, and hence we can get our what? Equation. There is equal to, this is the equation, is equal to L2 all over A2 E2. Why are we able to do it? Because of this constant, and we got the constant from the question, the same material, and everything that happens here, mind you, is proportional to what happens here. Hence, we can equate them with each other. So L1 from the question, from the parameter, L1 is L, A1 is A, then E1 is 8 times 8. Okay, which is equal to L2 is what? Is L2 is 2L, A2 is 4A times E2, which is what we are looking for. Then since E2 is what we are looking for, we make E2 the subject of formula. Now, since we are making E2 the subject of formula, what we just do, everything here, this is, if we cross here now, you see one line here, you see another one, like everything here we multiply, it will be at the top. A times 8 times 2. Okay, we multiply everything here, divide by everything here apart from E that you removed here, divide by everything here, which is L times 4E. So everything here apart from E, that's how to easily do this. Then this one, A will cancel A, this one is 2L, sorry, This L will cancel L, which is equal to, will now give us equal to 8 times 2 all over what? 4, which will now finally give us the answer of all 4 millimeter. So this is the final answer to this particular question. And thank you for watching. And if there is any question, if you still do not understand, just ask your question on the comment section. If you are in Edo State, Benin City, and you are looking for physical classes, we are in Edo State. Fruitful Grand Tutorial is in Edo State, Benin City, Saple Road, Bypass. We are close to Belesima Junction at Oha 1. Do well to come and join us in our physical classes. Thank you. We'll meet in our next video. Bye.